Factorize 6a squared b minus 9ab squared. So what we want to do is take out the HCF, the highest common factor, which is 3ab. So 3ab divides into 6a squared b and leaves us with 2a. And 3ab divides into minus 9ab squared and leaves us with minus 3b. So I'm going to actually do this out using a bit of rough work just to show you where I got my answers from. So 6a squared b can be rewritten as 6a b. So 6a squared b can be rewritten as 6aab. And we're going to divide that by the HCF, which is 3ab. So where did this 3ab come from? Well, first of all, 6 and 9 can both be divided by 3. We have a squared and a, so a single a is common to both. And we have b and b squared, so a single b is common to both. So 6a squared b is going to be divided by the HCF, which is 3ab. So 6 divided by 3 is 2. That a will cancel with that a. That b will cancel with that b and leave us with a. So that's where the 2a comes from. And next we're going to divide minus 9ab squared by 3ab. So minus 9ab squared can be rewritten as minus 9abb. And we're dividing it by the HCF. So minus 9 divided by 3 is minus 3. That a will cancel with that a. That b will cancel with that b, and we're left with a single b. So we've got minus 3b. Factorize 25x squared minus 16y squared. So the first thing we would do is try the HCF. So there's no number that will divide into 25 and 16, and there's no letter common either. So we can't use the HCF method. Hopefully you would notice that 25 is a square number, x squared is a square number, 16 is a square number, and y squared is a square number. And there's a minus in between. So we're going to use the difference of two squares. So the square root of 25x squared is going to be 5x. Because the square root of 25 is 5 and the square root of x squared is x. So 25x squared can be rewritten as 5x all to be squared. You don't necessarily need this step, you can jump straight from the question down to our two sets of brackets. So then I'm going to get the square root of 16y squared. And the square root of 16y squared is 4y. Because the square root of 16 is 4 and the square root of y squared is y. So 16y squared is the same thing as 4y to be squared. So for the difference of two squares, we have two sets of brackets. We put the square root of the first term, so the square root of 25x squared is 5x. So that goes in the front of both brackets. And then the square root of 16y squared, which is 4y, goes in the back of both brackets. Now it does not matter if the minus comes first or the plus, so long as the 5x is at the front of each bracket and the 4y is at the back of each bracket. So we can check if our answer is right. So once we're asked to factorize, our answer is the two sets of brackets. But we can check are we right by taking the two sets of brackets and multiplying them out again. And we should get back to what we started with. So we have 5x minus 4y multiplied by 5x plus 4y. So 5x times 5x, so 5x multiplied by 5x is 25x squared. And 5x multiplied by 4y is going to be plus 20xy. And minus 4y multiplied by 5x is going to be minus 20xy, and then minus 4y multiplied by positive 4y is going to be minus 16y squared. And then 20xy and minus 20xy is going to cancel, leaving us with 25x squared minus 16y squared, which is what we started with. Factorize difference of two cubes. So the formula for the difference of two cubes is x cubed minus y cubed equals x minus y multiplied by x squared plus xy plus y squared. So if we're asked to factorize 8x cubed minus 27y cubed, well, the first thing here you would do is see, can you use the HCF method? So is there a number that will divide into 8 that will also divide into 27? And the answer is no. Then we have a look and we see, is there a letter common to both? So we have an x cubed here and a y cubed there, so no, there's no letter that's common to both. Then you might say, well, is it the difference of two squares? Well, 8 is not a square number, x cubed is definitely not a square number, 27 is not a square number, and y cubed is not a square number, so it's not the difference of two squares. So hopefully you will recognize that 8 is a cube number, x cubed is definitely a cube number, 27 is a cube number, and y cubed is definitely a cube number. So there's a minus in between, which tells us that we're going to use the difference of two cubes. So you have to learn off this formula, and it is actually quite common in the Leaving Cert higher level exam questions. It does not come up in the Leaving Cert ordinary level, however. So you do need to learn off this formula, and you also should learn off the sum of two cubes formula, which has a plus in between here. It's the same layout, just the signs are different. Okay, so we want to start off by getting the cube root of 8x cubed. So the cube root of 8x cubed, well, the cube root of 8 is 2, because 2 by 2 by 2 is 8, and the cube root of x cubed is x. So 8x cubed can be rewritten as 2x all to be cubed. So 2x is going to be our x value. So everywhere you see an x in our formula, we're going to swap it for 2x. We're not swapping it for 2x cubed, we're swapping it for 2x. So now we're going to do the same with 27y cubed. So the cube root of 27y cubed is going to be 3y, because 3 by 3 by 3 is 27, and y by y by y is y cubed. So the cube root of 27y cubed is 3y. So 27y cubed can be rewritten as 3y to be cubed. So everywhere you see a y in this formula, you're going to swap it for 3y. You don't swap it for 3y cubed, you swap it for 3y. So we're going to have x minus y, and we know that the 2x is really equal to the x in the formula. So everywhere we see an x, so every yellow part is going to become 2x. So we're going to have 2x, and that's going to be minus y. And the 3y is going to be our y value in our formula. So everywhere we see a y in our formula, we're going to swap it for 3y. So x minus y is really 2x minus 3y. So then we have x squared, so we're going to have 2x to be squared, plus x times y, so plus 2x times 3y, so plus 2x times 3y, plus y squared. So remember, y is 3y, so it's going to be plus 3y to be squared. So 2x minus 3y we just bring down, we don't do anything with that. And then 2x all to be squared means 2 squared, which is 4, and then x squared, which is x squared. So we get 4x squared here. 2x times 3y is 6xy. And 3y to be squared is going to be 9y squared, because 3 squared is 9 and y squared is just y squared. So this is our final answer. We don't have to do anything else with it. And remember, you can multiply out these brackets so you can crack open this egg. So you can do 2x times 4x squared, and then 2x times 6xy, and then 2x times 9y squared, and then minus 3y times 4x squared, minus 3y times 6xy, and minus 3y times 9y squared, and you will get back to what you started with. Okay, so let's try it. Let's multiply out these brackets and see do we get back to the start. So we have 2x multiplied by 4x squared plus 6xy, 9y squared. And I'll work that part out first. So I'm doing 2x multiplied by 4x squared, and 2x multiplied by 6xy, and 2x multiplied by 9y squared. And then afterwards I'll multiply in the minus 3y. So 2x by 4x squared is 8x cubed. 2x by 6xy is plus 12x squared y. 2x times 9y squared is plus 18x y squared. Okay, so now I'm going to multiply minus 3y by 4x squared, and then minus 3y by 6xy, and then minus 3y by plus 9y squared. So minus 3y by 4x squared is minus 12x squared y. Minus 3y by 6xy is minus 18xy squared. Minus 3y by 9y squared is minus 27y cubed. So the 12x squared y and the minus 12x squared y will cancel. The 18xy squared and the minus 18xy squared will cancel. And we're left with 8x cubed minus 27y cubed, which is what we started with. So our answer in the brackets is correct. So in this example, we have the sum of two cubes. So the formula for the sum of two cubes is x cubed plus y cubed is equal to x plus y times x squared minus xy plus y cubed. So again, you need to learn this off by heart. It's very, very, very similar to the difference of two cubes, but the signs are different. So learn this off by heart. So here we have 1 plus 1000p cubed. Now, we're asked to factorize, and the first thing we'd always try is the HCF. So you could say, okay, well, 1 will divide into 1 and 1 will divide into 1000, but we don't ever want to use 1 as a factor. So apart from 1, is there a number that will divide into both? And no, there's not. In terms of letters, well, 1 on its own doesn't have any letters attached, so there's no letters common to both. So there must be a different way to factorize this. So there's no minus in between, so we automatically know there's no difference of two squares and there's no difference of two cubes. So we do know that there is a formula for the sum of two cubes. So we have to check, is 1 a cube number? And yes, it is, because 1 by 1 by 1 is 1. Is 1000 a cube number? And yes, it is, because 10 by 10 by 10 is 1000. And p cubed is definitely a cube number, because anything cubed is a cube number. So the first thing we want to do is get the cube root of 1. So the cube root of 1 is just going to be 1, because 1 by 1 by 1 is 1. So 1 can be rewritten as 1 to be cubed. And next we want to get the cube root of 1000p cubed. So the cube root of 1000p cubed is going to be 10p, because the cube root of 1000 is 10 and the cube root of p cubed is p. So 1000p cubed can be rewritten as 10p to be cubed. So in terms of our formula, 1 is going to be our x, and 10p is going to be our y in terms of our formula. So now all we have to do is substitute into our formula. So we have bracket x plus y bracket. So we're going to have bracket 1 plus 10p bracket, because remember x is equal to 1 and y is equal to 10p. So we have 1 plus 10p. Next we have x squared, so it's going to be 1 to be squared, minus x times y, so minus 1 times 10p, so minus 1 times 10p, plus y squared. And we know y is equal to 10p, so it's going to be plus 10p to be squared. So 1 plus 10p, we don't do anything with that, we just bring it straight down. 1 squared is 1, minus 1 times 10p is just minus 10p, and then 10p squared is going to be 100p squared, because 10 squared is 100 and p squared is just p squared. So here we have our answer, what's inside the brackets. Now, just like in the last example, you can multiply this out and you'll get back to what you started with. Factorize 6pq plus rs minus 2sq minus 3rp. So we have 4 terms, and we have a look and we see is their HCF, is their highest common factor. And you will see that there is no number or letter that will divide into all 4 terms. So since we have 4 terms, we're not going to use the difference of 2 cubes or the difference of 2 squares or the sum of two cubes, because we have obviously more than 2 terms. And we're not going to factorize using our arrow method, which is quadratic trinomials, because we have 4 terms, not 3. So we're going to do factorization by grouping. So what we have to do is group the terms together so that they have a HCF between 2 of them. So 6pq and rs, there's nothing common to both of them. And minus 2sq and minus 3rp, again, there's nothing common between those two. So since there are no common factors in the first 2 pairs or the last 2 pairs, therefore we have to rearrange the terms. So we start off with 6pq plus rs minus 2sq minus 3rp. So we're going to rearrange the order of the terms so that they are grouped. So the 6pq and the minus 3rp can go together because we can get a HCF of 3p. And then the rs and the minus 2sq can go together because we can get a HCF of s. So we've put them into pairs with a common factor. So next we factorize the first 2 terms. So 3p is the HCF of 6pq minus 3rp. So 3p divides into 6pq, leaves us with 2q. 3p divides into minus 3rp, leaves us with minus r. Then we factorize the right 2. So the HCF of rs and minus 2sq is s. So s divides into rs, leaves us with r. S divides into minus 2sq, leaves us with minus 2q. Now, hopefully you notice that what we have inside the brackets is very, very similar. We have a 2q and a minus 2q, and a minus r and an r. So they're almost the same, but what we're going to have to do is change the signs in the second bracket. So s times r minus 2q, so s times r minus 2q is going to become minus s times positive 2q minus r. So we change the signs of everything. So 3p times 2q minus r stays the same, we just bring it down. Positive s becomes minus s, r becomes minus r, and minus 2q becomes positive 2q. Now our brackets match. So 2q minus r is going to be one of our factors. We bring down the 3p and the minus s, and that's our other factor. So we can multiply out these terms. So this is our actual answer. We were asked to factorize, and here we are. But we can multiply this out, and we should get back to this, the start. So, important to note, this expression, so what we started off with, could have been rearranged into pairs with common factors in other ways before factorizing, such as 6pq minus 2sq minus 3rp plus rs. So factorising the first two, our highest common factor would have been 2q. And then factorising the right two terms, so minus 3rp plus rs, our HCF, would have been plus r. And you would have continued on, put your values into your brackets, and then you would have ended up with the same answer. Likewise, it could have been arranged like this. So factorising the first two, we would have 3p as a HCF. And then factorising the second two, we could have had plus s as our HCF. And again, you would have continued on, filled your brackets, and put your two sets of brackets together at the very, very end.